have wondered, how did the universe originate? Well, there was this theory called the Big Bang Theory, which is the leading explanation for how the universe originated. Before the Big Bang Theory, a physicist named Albert Einstein had a theory about the origin of the universe. Albert Einstein was a German-born theoretical physicist, widely acknowledged to be one of the greatest and most influential physicists of all time. In his origin of the universe is finite, has an unchanging density, and has a homogeneous composition. Albert Einstein proposed a temporally infinite but spatially finite model as his preferred cosmology during 1917 in his paper Cosmological Considerations in the General Theory of Relativity. However, in 1927, Georges Henry Joseph Edward Lemaître has revised Albert Einstein's theory of the static universe. Georges Henry Joseph Edward Lemaître was a Belgian Catholic priest, theoretical physicist, mathematician, astronomer, and professor of physics at the Catholic University of Louvain. Lemaître demonstrated in Einstein's theory of relativity predicts that the universe is expanding based on three main key evidences. The Hubble's law was discovered by Edwin Powell Hubble. Edwin Powell Hubble was an American astronomer, and he played a crucial role in establishing the fields of extragalactic astronomy and observational cosmology. During the 1920s and 30s, Edwin Hubble discovered that the universe is expanding, with galaxies moving away from each other at a velocity given by an expression known as the Hubble's law. The Hubble's law shows the mathematical relationship between the distance from the Earth and rate of expansion observed. It implies that galaxies are constantly moving away from the Earth at velocities proportional to their distance. This means that the universe is expanding uniformly in all directions. In 1948, it was suggested that if the universe started from a single point, there should be microwave background radiation in space left over from the expansion. This radiation was discovered in 1964, called the Cosmic Microwave Background Radiation, or the CMBR. This was discovered by the American radio astronomers Robert Wilson and Arno Penzias. CMBR is a second piece of evidence to show the expansion of space. It suggests that the short wavelengths of the gamma radiation emitted in an initial point are believed to have become stretched due to the expansion of space into longer wavelength microwaves. Lastly, the third main evidence of the Big Bang Theory is the nucleosynthesis, which describes the creation of elements as well as the presence and the relative abundance of helium and hydrogen in our present universe. The Big Bang started as a very small entity called a singularity, in which all matter are condensed into one. Due to the content compressed of this small entity, there was high energy density. There was an equivalence of mass and energy during that time, which means that energy is proportional to mass. This explains Albert Einstein's energy and mass equivalence equation. During the Planck era, the energy exists as a force called the superforce. There was a high temperature during this era because of high energy, which led to the expansion of the universe. So, to make it clear, Big Bang is not an explosion, but rather it has an expansion of singularity. Due to its expansion, the temperature will decrease and the superforce will be divided into two. The GUT, or the General Unified Theory Force, and gravitational force. During the GUT era, there was a continuous expansion of the universe. This was then called the inflationary period because of its sudden increase in expansion rate. Due to its expansion, the temperature will decrease and the GUT force will be divided into two: the strong nuclear force and the electroweak force. During the electroweak era, the supernuclear force and electroweak force are separated further because of the continuous decrease in temperature. Upon the separation of the strong nuclear force, gluon, quarks, and antiquarks are produced, which is then called the quark-gluon soup of the universe. And the particles of these quarks contains neutrons and protons in the form of baryons and hadrons. The electroweak force, on the other hand, separated further into two: the weak nuclear force and the electromagnetic force. During this era, the four fundamental forces of nature are formed. They are the gravitational force, the strong nuclear force, the weak nuclear force, and the electromagnetic force. These four fundamental forces served as the building blocks of our universe because they are believed to produce the particles of the universe. The weak nuclear force has produced bosons, leptons, and anti-leptons during this time. And leptons includes particles such as electrons. At the end of the electroweak era, all necessary particles are complete to form an atom, calling the next era as the particle era. The Big Bang nucleosynthesis, or the primordial nucleosynthesis, started 3 minutes after the Big Bang event. During this era, deuterium, an isotope of hydrogen atom, is created by the fusion of one proton and one neutron. The combination of two deuterium nucleus created a helium nucleus. Most of the nuclei created during this era are destroyed upon passing a photon, but some of the nucleus has still remained. This then led the universe to be made up of electrons, 70% hydrogen, and 25% helium that lasted for 5,000 years. During the nuclei era, there was a recombination process which makes atoms stable. This is a process in which there is a creation of neutral atoms through the trapping of electron of ionized nuclei. During recombination, photons stream freely through space, which we know as the lights of the universe. The release of energy then causes lesser light, resulting to a dark void. Lastly, the era of galaxies includes the process of forming new elements inside the stars. It is described that stars are made through two steps: through nuclear fusion and thermonuclear reaction. Stars are first formed through nuclear fusion or clumping of hydrogen by gravity. Then, thermonuclear reactions occurred through exothermic reactions and and burning reaction. Exothermic reaction involves the creation of elements hydrogen to helium, and it creates low-mass stars and high-mass stars. And burning reaction involves the creation of elements helium to iron. If the elements were to create elements that are heavier than iron during the thermonuclear reaction, it would result to the creation of supernovas, black holes, and hypernovas of the universe. So this is all the origin of the universe and the Big Bang Theory.